Guitar intervals, C major, A minor, and related modes. This time looking at the Aeolian mode, otherwise known as the A minor scale, focusing in on the bottom string of the guitar, this thin E string, fret number 5. This is part number 3. One point of primary focus for us is to line up all of our resources in the same direction, making them as easy on the eyes as possible from the perspective of the player of the guitar, who is of course located behind the guitar. Therefore, for example, my guitar is going to look like I'm playing left-handed, but no, we just flipped the guitar around to mirror your perspective from behind your guitar as though you were playing it into a mirror. Similarly, our Excel worksheet, which is representing the fretboard, is going to have this representing the low or heavy E string, the one closest to the ceiling, top to bottom, left to right, situated as though we just took our guitar and imprinted these strings on that screen. We're going to now be looking at this A note and making our intervals around it using this shape, which means we're basically going to be looking at the Aeolian, or the minor scale, around this note. So remember, one of the ideas here is that we're going to be at the bottom of the guitar. A lot of people don't really think about creating intervals from the bottom of the guitar, which is one of the major ways that you can build chords, is by basically putting together the intervals, the main intervals that we would want to know for a triad being the 1, 3, and the 5. So I want to talk a little bit more about that as we go into basically our intro here, to try to get an idea as to why you might want to spend, a few minutes a day, 15 minutes, an hour a day doing an exercise of something like this, to try to get some of that theory stuff in our mind, so that then we can kind of expand on it when we're doing kind of noodle around practice, more freestyle stuff, or whatever we want to do. So remember, the general idea here is that we want to be working on our intervals. We're focusing here on the minor scale, noting that the minor scale could also be thought of as the Aeolian mode, just one of many modes, just like looking at a fractal picture or something like that. There's no better mode when you're perceiving it that way than anything else. It's just like in physics when you're looking at one perspective versus the other perspective. What we want to be able to do is look at it from each of the perspectives, even though the scales that are used the most are going to be the minor scale, Aeolian mode, and the major scale, the Ionian mode. But we would like to see it in conjunction with all the other modes, in part because that allows us to build chords a lot more easily, no matter what mode we're playing in, even if we want to stick to those main two, the major and minor scale, the Ionian mode and the Aeolian mode. So how can we learn those? Well, we're going to start with the major scale typically, because again, in Western music, we use that as the key. We might as well keep doing that. As we use it as the key, however, we want to not get stuck thinking about like a convention, as though it's a rule, as it's a law. And I just want to put this thought out there. I'm going to compare it to something that I've been kind of thinking about a little bit, which I think has a parallel to it. You might not agree with my thought process on this thing, but you can get the idea, right? And the idea would be, for example, when we were working on scientific understanding of things and looking at the universe and whatnot, it became a good convention to say, hey, look, I'm going to look for the simplest explanation of something, number one, so that's going to be most likely the best outcome will usually come from the simplest explanation. And number two, I'm not going to look for a supernatural cause, but I'm going to try to look for another physical cause in the world as I do tests. And therefore, as a general practice, I'm going to remove like the idea of, well, God did it, right? It was a spiritual thing that caused this thing to happen, right? Now that's a general rule within science that makes sense, but it's not really a law, right? We can't really make a law saying, well, this is actually the way it has to be because it's the simplest thing, right? You can imagine a simple idea of something that isn't correct, that is more simple than a more complex idea. So it's a general rule that scientifically you're going to find the quickest point between two things, a cause and effect, but it's not, you can't apply it all the time. And you can't really say all the time. I mean, you can't rule out with science like a god or something like that either, in my opinion at this point in time, because again, it's hard to see scientifically what's happening from the realm of physical items and think about something that might be outside the realm, right? If you're thinking about multiple dimensions or something like that, you're not going to be able to prove that, scientifically, because now it's outside the realm of the physical realm, right? So it's a general convention to be able to say, what I'm going to do scientifically is I'm going to look for the simplest solution, and I'm going to eliminate basically the acts of God in my explanation so that I can keep drilling down on the complexity of the world to find the physical rationale for things and try to drill that back as far as we can get it without having to resort to supernatural interventions. That makes sense, but again, it's just a convention. And similarly here, what we want to do is use the major scale as kind of like a key, right? The major scale is a key that we can refer back to. It's a general rule to say, okay, that's going to be like the primary scale, and then all of the other modes are basically derived from that major scale. That works because it gives us an angle, a point of reference. But that would be just like saying that if I'm on planet Earth and I'm measuring everything from planet Earth, that planet Earth is the center of the universe, and it's not that way typically, but it's useful to measure that way when I'm in Earth, right, to do many things, right? So similarly with music here, the major scale is what we kind of use to as our perspective, but it's useful to note that obviously all the other modes, you can derive everything from all the other modes. They're just as useful to look at it from basically that perspective. It's a convention to basically say that we're going to use the major scale, which is quite useful for us to do, but it's not like a law, if that makes sense. That's my rant on that. But generally, why does it make sense for us to do it? Because if I learn the major scale intervals, if I learn these intervals, then I can also learn the related modal intervals by basically comparing them to the major scale. The two other major modes, the one that have a major third to them, only have one interval difference, making it easy. And then the minor mode, the Aeolian mode, is basically, you can almost think of it as the opposite of the Aeolian mode. So that means that the perfects remain the same. The majors will be flipped to minors, except for that weird second, which stays major. And then if I can memorize that, then I can compare the other minor modes to the major mode. And there's only going to be one interval difference. Why is that useful? Not only because it lets me play in multiple modes, it also lets me maneuver from chord to chord, no matter what mode I'm playing in, to be able to determine not only it's a major or minor, but also what 7, 9, 11, and 13 will fit into the chord. So that's going to be basically our general outline. So something I'd like to point out in terms of, well, how could you, once we start learning these intervals, one way that you might put this into practice, let's go down to the minor scale and just let me look at the intervals real quick. You've got a 0 note away perfect first, a 2 note away major second, a 4 note away major third, a 5 note away perfect fourth, a 7 note away perfect fifth, a 9 note away major sixth, an 11 note away major seven. If I go down to the minor scale down here, then you've got a 0 note away perfect first, a 2 note away major second, which is the same, even though it's a major second for the minor scale. You've got a 3 note away minor third, flattened third, that's what we expect. 5 note away perfect fourth, 7 note away perfect fifth. Those are the same on the major and the minor. And then we flattened the sixth, 8 note away minor six instead of a major six, and a 10 note away flattened minor seven instead of an 11 note away major seven. So that's the general idea. Now, one thing that you might kind of do to put this into practice generally is, obviously, when you start to notice that I've color-coded the minors, the 1, 3, 5 of the A minor here as the 1 is green, the 5 is yellow, and then the 3 is red. So one thing you can do is, of course, build chords from the bottom by basically using your intervals, being able to count the intervals, and then measure each of them from the root note. So how would I do that practically? Clearly, what I would normally start doing is saying, okay, I'm in whatever mode I'm in. If I'm in the Aeolian mode, I can go in here and look for all my A notes, and then I can basically look for the 1-3-5 relationship and start building chords from it, and then I can expand on that by going to the 7, 9, 11, and 13. If I'm in A minor and then I go to like the 3, for example, that means I'm basically playing the C, which if I'm in the same key will be a major modal chord, meaning if I started from the C, I would be playing a major chord. So I could stay on this worksheet and say, well, now, like if I'm going to a C up top, I could use my intervals and major the 1-3-5 from using this as my center point. I could use this same worksheet, or if I want to color code it like this, I can say, well, now when I go up to the 3 of the minor scale, I can scroll up and say, well, I'm basically playing a major modal chord. So you can go up to this worksheet and say, now I'm building the 1-3-5 because I've color coded that up here as the 1-3-5 and make it a little bit easier to see. But see what I'm doing is I'm thinking of myself in the key of A minor. It's just that I went to the C as it relates to A minor in my chordal progressions, and when I go to the C, I'm going to think of it as a major modal chord, right? And then if I go back down to if I'm playing in A minor, then I go back to the A minor, right? And then if I wanted to go to the D, notice it's a Dorian modal chord, which I can see right here. These are all the notes in the Dorian modal chord. Or I can go up to the 2 of my modes, right? And say, here's the Dorian as though it's the first, so that I have it color coded with the 1-3-5. So you see how they're all related. That'll make it a little bit easier possibly for me to see these other notes that are involved. Now you can also do this the other way, which I would recommend, playing with, and that would be, let me just find different fingerings on the guitar and then see if I can determine what I might name that chord, right? Instead of first thinking about the chord that I want to find and then finding it, looking for the root note and building a chord around it. Maybe first I'm just going to say, hey, this whole shape, all these colored notes are in my shape. Let me go into the shape and I'm just going to grab whatever I can. I'm going to think about it in 3 notes at a time to build some kind of triad chord. And then I'll go back in and try to figure it out. Now, as you do this, it's useful to think about 3 notes at a time. Like you might pick like the middle of the guitar, like these 3 strings, right? Because I'm using 3 fingers, so I'm going to try to pick 3 strings. I can't fret 2 things at a time if I'm building a chord. So there's only so many combinations that you could have, right? So if I'm like in the middle of the guitar and I'm looking at like these 3 strings, maybe I start on the G string, and what are the different ways I can do it? I could, usually people think about going below it here down to here, but if I want to stay in these 3 strings, I would go up top here and then below it, right? So now I've got, if I'm here, I'm going here, and then I'm going up top here, and then I'm reaching over here, right? Now that's kind of a weird, that's kind of like, wait a sec, I need to be reaching out here. Did I do that right? Yeah. No, wait a sec. I went, wait a second, what am I doing here? It goes here, here, and then here. That's what I was doing. So notice, and then you can kind of figure that out. It's like, oh wait, there's 2 E's in that one. And then you can kind of look at the intervals related to them. So I'm trying to pick a fingering structure that I don't use like all the time, right? So I can pick like this structure, like this, which I already know is like an A minor. So the ones that are going to come to mind are going to be the ones that you're familiar with. But you can start to say, well, what if I reach my finger down this way on this G, and then I reach below it right here, and then it's like, well, what can I do above it? I can go up to here. So now notice what I'm doing is I'm reaching now, instead of reaching down here with this finger, which is the most comfortable thing to do, I'm reaching down with this finger, which gives me more breadth up the guitar. So if I reach it down there, that's going to make it easier for this finger to reach, although I have a big gap here. And now I've got now I've got this chord, right? And then I could look for where I can put my pinky down, which would be right here. Is that right? No, right here. So then that's like, okay, that's a weird chord. But now I could measure it using my intervals, right? I could say, well, when could I use that in a practice? And normally I would look at it from the perspective of where my root is. The lowest note in the chord is actually this, right? So I could think of it as an F chord and say, well, then there's a G related to it. How far away is that G? Well, it's going to be, if I count this out, it's going to be 5 here, and then 4, 3, 2. So if I think about it from the perspective of an F, then it's got then I'm going to be playing in the F, which is going to be some kind of Lydian modal chord, right? Because I'm playing on the F, on the Lydian note in this key. So it's going to, and then it's got a 5, 4, 3, 2, a major second, and then it's got 5, 10, and then 9. So it's got a major 6 in it. Or I can measure it from the G. I can think of it as a G chord because it's kind of ambiguous, because you notice that it doesn't have the third. So that if it doesn't have a third in it, it's difficult to say if it's major or minor. It's kind of in between. So I could think of it as an F. Maybe when I get to an F, I put that chord in there and see what it sounds like if I have a progression with an F in it, an F chord, just to make it sound a little weird, right? A little different. Or I can measure it from the G, in which case if I measure it from the G, I'm going to say, okay, this is 5 up here, and then we're going to go 5, negative 5, 4, 3, 2. So that means that from the perspective of the G, it has an inverse of a 2. So it would be a 10. So that would be a 10 note away, which would be a minor 7, right? I'm trying to do this fairly quick. And then if I go down below it, I've got 5, 6, 7, a 7 note away, which is a perfect fifth. So again, I can think of it as a G chord and try to think about what kind of G chord basically I'm looking at it, or I can think of it as a D and look at it from that perspective, in which case I've got like, what is this, a negative 5, negative 6, negative 7. It's an inverse distance because I'm going above it, so 12 minus 7, if I measure it from the D, is a 5 is a 5 note away, which would be a perfect fourth. And then if I go up to this one, I'm looking for the inverse distance, or I can count out the inverse distance, which would be 5, 10, and then 9, and then 12 minus 9 is 3. So there's the third. So if I look at it from the D, then I actually have like a minor third in there. So I could think of it as a D. Actually makes kind of the most sense in this case, even though it's the highest pitched note, because it has the third in it, which, right? So notice that either of those ways of looking at it isn't necessarily wrong. It kind of just depends on what context you're in, right? Because it could sound like an F, even though you can think of it as like some kind of D minor chord, because the F is going to be the lowest note. So it might still work if you're in a progression. Now notice you don't really need to know that in order to noodle around with this shape. Like if I took the same concept, like I'm always starting with my pointer finger here, and then I'm going to reach down to the string below it here, and then I'm going to reach whatever's available above it after that. So I'm reaching down to here. I could reach this one, but I can't really get that if I use my second finger, so I have to go out to here. So it just makes sense just by where I put that second finger in terms of where my third finger is going to go. And that same shape then, if I moved it back and I did the same pattern, I can move it back here. It's useful to just go up and down the guitar and play the same pattern, right? So I can say, okay, it's going to be here. So now if I did that same pattern and then I go back to the next available thing, it's an F, and then I say, what can I reach down below it? Well, I can reach that one. Down below it, the B is right there this time, and that just leads my finger up here to be on the D. So that you get like a tension-y sound there from the perspective of the F, because now you have a flat fifth because you're playing on the F, which is the Lydian mode, which has, you can call it an augmented fourth from the perspective of a Lydian that has the same distance as a flat fifth. And then if I go back to this one, then I'm going to go, okay, if I'm on that one, I basically have the same thing, right? So I could put this finger back, and I'm still reaching here and then here, right? And so I can follow that, and then if I went up from here, I started on the G, and if I do that same pattern, I'm like going to go down here, and then up to here, right? I was on here, on the G, down to here, up to here, and then I'm going to go up, and say, what can I do with this pattern? If I did the same thing up here, I would be like on the A, and that means I'd reach down to the E, which is going to lead this finger here, right? So if I start on this A, and I'm like, I'm going to reach down to whatever I can reach in the pattern, that's going to be an E, and then up here, where can my finger go? It can go on the G. So if I start to play that, like, you can start to play those up and down. You could start to learn those patterns that are a little bit different, not by like figuring out the interval or seeing exactly the chord that you want to play, but just playing the same pattern, just like you do when you're playing like the blues. Because it's the same pattern, basically, it's going to work on the same strings up and back. And in this case, you're playing it, you're not keeping the shape the same. You're changing the shape, but keeping the same idea of I'm going to reach this string down. I'm going to put my finger in this string, and I'm going to reach down here, and then I'm going to put this finger on whatever fits in the pattern. And then I'm going to go to this string, and I'm going to go down here, and I'm going to do whatever fits in the pattern, and then reach up here to whatever fits in the pattern, right? And then I'm going to go here and do the same thing, fit whatever fits in the pattern. And that's going to sound somewhat coherent because it's a similar shape, but you've changed it to fit in the key, so it's always going to fit in the key, and that'll help kind of get the shape down. And again, you can do it, you can then try a different one, right? Like, and then I can go, like I can say, well, what if I reached like up here and then down here? Like, okay, what if I was like here, and I'm like, I'm going to go pointer, and then I'm going to once again reach with this finger instead of this finger up there, which makes this finger have to point out here, and I get to that, and then I could put this other finger down somewhere. And like, okay, what is that? Well, what if I move that same idea up here? Then I'd be on this A, right? And then I would reach up. What can I reach up here? I can reach the C now, which is now here, and then that's going to leave this finger going to whatever fits in the pattern there, right? And now this is kind of it has a 7 in it from the perspective of if you think about this as the root, you've got the 1, 3, and then like a 5. This would be an A minor kind of inverted with a 7, with a 7 in it, basically, right? So if you think about it from the perspective of the A, but you could then, again, then if you want to practice your theory with that, then look at all those weird shapes you've made and try to see, can I look at it from the perspective of each note in the triad as though it's the root, measuring from the perspective of the A, measuring from the perspective of the C, measuring from the perspective of the G. I'm not an expert in that, but that's kind of what I'm kind of noodling around with, because that means that we can, instead of counting this out to something I already know, instead we're looking at something we don't know and then trying to use our ability to count the intervals to think about what the chord is from the perspective of each of these areas, which again, to me, helps us kind of orientate our mind to look from different perspectives, breaking the model of making the convention the rule. The convention isn't the rule. The convention is a convention that we're using to help us with a particular thing, but doesn't work all the time because it's not a universal rule. Physics only has a few rules. I don't know how many rules are in physics, but there's only a few laws. You can't just be making up other laws. They're not laws, they're heuristics. Everything else, heuristics are good, but they're not a law, okay? They're not the law. Okay. Anyways. You start saying a heuristics a law, you're going down the wrong track, man. That's where you get messed up at some point. You're looking at it wrong. Okay. Let's go ahead and do a joke before we're going to go to this one. But let's try a joke. It's kind of a long one here. But here we go. Joke practice. In the movie The Caddyshack, a pretty old movie, back when people they actually aspired to say funny stuff without fear of having their car set on fire. In the movie, Chevy Chase says, "A donut with no hole is a Danish."
The Zen philosopher Basho once wrote, "Flute with no holes is not a flute, and a donut with no hole is a Danish."
Which I was thinking about, but it really, like this perspective thing we're talking about, it really depends on your perspective, because to a Frenchman, it's the Danish with a hole is a donut, because they see the world in like Danish form, while we see the world in donut form. They see the world as not having holes, while we see the world having holes. It's a matter of perspective. Like a case of you say tomato, I say it the right way. Honestly, can't you read tomato? It's ridiculous.
Mr. Quimby, did you assault Mr. Lacoste?
Of course not. I love each and every living thing on God's green earth.
Well, therefore, you certainly would never lose your temper over something as trivial as the pronunciation of chowder.
That's chowder! Chowder! I'll kill you! I'll kill all of you! Especially those of you in the jury!
Wow, that didn't go well. The defense round.
I still had not been convinced to buy an electric car, but now that I see the utilitarian practical benefit of the electric car due to no gas tank, the Tesla has proven itself much more difficult to set on fire or blow up by the crazy commies. I'm starting to think electric cars are the way to go here. I mean, we really can save the environment with the Tesla electric cars, because they can prevent the crazy environmentalists from releasing massive amounts of CO2 emissions by burning cars. If we could just stop those environmentalists from burning the cars with the electric cars, we'll save the world. Honestly, and those environmentalist types are straight up lighting up entire dealerships while forcing everyone to drink soy milk because of CO2 emissions of cow farts. It's ridiculous, man. Like, what is, like, you take away my milk and CO2 emissions will go higher because my emissions will be greater than the emissions of cows. Why? Because I'm pissed off, okay? It'll piss me off. Pissing people off with crazy laws, it upsets people's stomachs, leading to CO2 emissions that will increase even greater than cow farts, okay? Don't piss people off. People need to be calm. You have to keep people calm, and then they'll fart less, and we'll have less CO2 emissions. Seriously, like I'm sitting over here in California, the land of the wussy water-saving toilets that require like the dumping of an entire bucket of water in the bowl just to flush the thing, while simultaneously having the worst water management for like a fire-prone area ever over here. And the politicians then are like lecturing me on how they plan on saving the environment. The California politicians will then blame the people. Just like Disney blames their own fans. They're like, well, it's your fault we had no water in the fire hydrants because you keep on dumping buckets of water into the bowls of toilets because they're wussy toilets. Bunch of scapegoating liars, I tell you. We got to get the scapegoating liars out of like the decision-making areas. That's not where the scapegoaters lie. They shouldn't be there. I mean, I'll trust the plan of the proven, market-tested, and approved successful engineer entrepreneur rather than the crazies who thought they'd save the state of California by mandating the use of wussy cans, okay?
The toilets today aren't worthy of the name. They come in designer colors, and they're too low. When you flush them, they make this little weak, almost apologetic sound. Not the Ferguson.
Elon Musk can help by building a car that can't be burned down by the environmentalists. That's what needs to happen. That's what he needs to do next. And think about how much think about how much nicer the Summer of Love riots would have been if the cars couldn't have been set on fire by the crazy commies. It would be so much nice. It would have been a lot nicer and save the environment. We left off last time on the 7-note away perfect fifth, so that's where we will be picking up this time, noting that this 5 represents the relative position number 5 in the scale we're working on, the Aeolian mode or minor scale. The 7 represents the distance from the first note in that scale, which in our case is the A note, because we're looking at the A minor or the A Aeolian, noting that the perfect fifth has the same interval on the major scale as well as our minor scale on the Ionian mode, in other words, as well as here on the Aeolian mode, and is in most of the modes. So that means that the fifth is one that we're getting a lot of practice with, and that practice is justified because the fifth is going to be in our major chord construction. So notice that although the fifth isn't the note that really defines a chord as major or minor, and therefore you can kind of think of the third as more important in that way than the fifth is one that you can put in there all the time. Almost all the time, right? Because the fifth is going to be there on almost every note that we're going to be looking at in our scale if I want to build a chord thinking of whatever note in the scale as, in essence, our root note, and the fifth and the first would be what we would call a power chord. So we can make a power chord out of basically any modal chord that we're working on from basically any note, except for when we're working from the Ionian, which doesn't have a distance of a 6-note away perfect fifth. Okay, so that's going to be the general idea here. And if I look at it from a chord construction standpoint, we're going to be back here on the fifth. So I don't need to name it something different because it's already an odd one, not an even. So it's the 1, 3, 5. So from a chord construction, it's also the fifth. We're measuring from the bottom, so I'm looking at this as my root note. If I was building a chord, a 1, 3, 5, then of course the fifth would be a major part of that, or I can build a power chord with just looking at the 5, the 1 and the 5, a 2-note chord, if you want to call a 2-note thing a chord. All right, so when we go above it, we have to look for the inverse distance, so I'm going to count that out. And the fault line is going to be from the B to the G. So from the perspective of us, we live on this continent. I'm thinking of this as a fault line. This is one of the tectonic plates here. This is the tectonic plate up top. When I go from top to bottom, I usually think of this plate, this tectonic plate, shifting to the right. But I'm thinking it's easier now that I'm identifying my heuristic down here when I'm on the bottom tectonic plate, is to think that when I cross the fault line, it's this continent that moved to the left. That's going to be easier kind of for me to see, which way I should go when I cross the fault line, because there's a kink in the tuning right there. All right, so let's do that. We're going to say I'm looking for the 7-note away perfect fifth. If I go on the same string, 7 notes is kind of a far way to go. I can't reach it as easily. Therefore, I'm going to imagine that I took this string, wrapped it in a circle, which would be like a clock with 12 steps in it. And if I go one side around the circle, it would be 7 steps. That would be the distance of 7. That means that if I go around the other side of the circle, I would only have to go 5 steps to get to the same spot. That's more reachable. So let's do that. So if I was on this A, I can go 1, 2, 3, 4, 5 back. If I went from the E to the A, whoops, that would be a 7-note away perfect fifth. If I went from the E to the A, that would be a 5-note away, which would be a perfect fourth, the inverse. If I go from the A to the E, we could think about that as the inverse, which would be a 7-note away perfect fifth. Let's go above it then. So if I go above it, I'm looking for this E. So if I go above it, I have to look for the inverse distance. So a 7-note away perfect fifth will have an inverse distance of 12 minus 7, which is going to be 5, noting that the inverse of the perfects are each other, which is convenient, yet a little bit confusing. So we have to keep drilling that in our mind, not to get those two mixed up, especially given the fact that a 5-note away distance is not a perfect fifth. That's the perfect fourth. The perfect fifth has a 7-note away distance, okay? So if I'm going above it and I'm looking for a 7-note away fifth, I have to take 12 minus 7 to get the inverse distance, which is 5. So, and that's going to be right above it because I'm not crossing the fault line yet. So I'm right there, right above it. So if I go from here up 1 to 5, top to bottom from E to A, that would be a 5-note away perfect fourth. Therefore, from bottom to top would be a 7-note away perfect fifth. That means if I go up 1 string, the 7-note away perfect fifth will be right above it, unless I cross the fault line, which would only happen on the B string. So if I was on this A, I would then cross the fault line. So the rule is, if I go up 1 string, the 7-note away perfect fifth will be on the same fret unless I cross the fault line. And notice if I'm looking from the perspective of this as the continent of this here shifted to the left. Therefore, from the perspective of me standing still on A, this shifted to the left above me, and therefore I have to have 1 step back. So if I go up 1 string, then the 7-note away perfect fifth will be 1 fret back. All right, let's go up another fret, another string. So we're going to go up here. Now we're crossing the fault line. We didn't cross the fault line here, but we crossed the fault line when we go across these two, looking for the 7-note away perfect fifth. So the inverse distance is 12 minus 7, a distance of 5. If I count that out, we're going to say 5 is the distance between these two strings, and then this continent shifted to the left from my perspective of the A. So to get another 5, I can't go straight up, but have to go this way, which would be 10, which I'm going to do even though I'm going away from the note I'm trying to get to, because I don't like to count in 4s. I like to count in 5s as I go up the strings. So I'm going to say that's 10, and then I'm going to call it negative 10, and then I go this way towards the positive. So negative 10, negative 9, 8, 7, 6, 5. Let's do the same lo mismo here. So 5 to here. This continent shifted that way, so 10 would be back here. 10, negative 10, 9, 8, 7, 6, 5. Boom. We're looking at that E right there. That's an E. So if I went from this E to the A, that would be a 5-note away perfect fourth. From the A to the E then would be a 7-note away perfect fifth. So if I go up 2 strings and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3, 4 frets, 1, 2, 3, 4 frets forward. But what if I didn't cross the fault line? If I started on the G or the D string, I wouldn't cross the fault line. For example, if I was on this A and I go up 2 strings, then it's going to be out here. Okay, so now, so that means that the normal idea would be if I go up 2 strings, the 7-note away perfect fifth will be 1, 2, 3, 4, 5 frets forward, unless I cross the fault line, which would happen on the bottom 2 strings, 2 out of the 4 times that I could go up 2 strings, right? And then if I go up 2 strings and cross the fault line, then the 7-note away perfect fifth will be 1, 2, 3, 4 frets forward. Why? Because from the perspective of the continent that I'm on, this continent shifted to the left, which made the distance shorter going to it. It moved. I stayed where I'm at. It moved. You're the one that moved. You're the one that moved. I've been here all the time. I've been here the whole time. Okay, don't you tell me I'm moving. You're the one that's moving. And they say, but then they say that anyway. So then let's go up 3 strings. So we're looking for the 7-note away perfect fifth. So we need the inverse distance, 5-note away perfect fourth. So if I go up 1 string, that's a distance of 5. This continent shifted to the left. So this is going to be 10 going this way. And then 15, there's only 12 notes in the musical alphabet. So every time I go above 12, I'm going to bring it back down by saying 15 minus 12. It's going to be negative 3. This way goes more negative, negative 4, negative 5. Let's count it out from here. So we go negative 5, this continent shifted, so it goes negative 10, and then negative 15. 15 minus 12 is negative 3, negative 3, and then 4, 5. So from here, this E to to this A. That would be a 5-note away perfect fourth. From the A to the E, therefore, would be a 7-note away perfect fifth. So that means if I go up 3 strings, the 7-note and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3 frets back. I wouldn't cross the fault line if I started from the G string. So if I went from this A up to here, then I would not cross the fault line. So the general rule is, if I go up 3 strings, the 7-note away perfect fifth will be 2 frets back unless I cross the fault line, which would happen on the bottom 2 strings, the B and the E string, in which case if I go up 3 strings and cross the fault line, the 7-note away perfect fifth will be 3 frets back, due to the fact that if I think about this continent being stable, then this one moved to the left, in this case making the distance longer because I'm reaching back, and this continent moved to the left from my perspective. Okay, so then let's go to the next one. And we're going to go up here. So we're looking for the 7-note away perfect fifth. Inverse distance is the 12 minus 7, which is 5. So distance of 5. So we got 5 here. This continent moved to the left. So we go 10 diagonal. And then 15, only 12 notes in the musical alphabet. 15 minus 12 is negative 3, plus another 5 is going to be a negative 8. When I go this way, I go in the positive direction. I'm on negative 8 is the way I see it. Negative 8, 7, 6, 5. So let's count it out this way. So I'm going to say negative 5. This move this way, so negative 10. Negative 15. 15 minus 12 is negative 3. Negative 3 plus another 5 is 8. And then I'm going to go 8. And then down to 5, so 8, 7, 6, 5. Boom, boom. So from this E to that A would be a 5-note away perfect fourth. From the A to the E, therefore, is a 7-note away perfect fifth. That means if I go up 4 strings, I will always cross the fault line because I can't go up 4 strings without crossing the fault line. Therefore, the 7-note away perfect fifth will always be 2 frets forward in that case. And then we can go it up to the top, which is the big distance one. Here's our giant equilateral triangle. 1, 2, 3, 4. Wait a sec, not quite uniform. No, this way is shorter. 1, 2, 3, 4, 5. That makes sense. Okay, so, but I would probably find that more easily because I know these 2 strings have the same notes on it by saying, let me find it on the same string. So if I'm looking for the 7-note away perfect fifth on the same string, I could go up 7, which would be up here, which would be the same on the top string of the guitar. Or I can take the inverse distance. If it's up 7, that means 12 minus 7 would be 5 back. 1, 2, 3, 4, 5 back. And if it's here, it's the same up top. But let's count it up to the top because that'll be fun counting practice. So we're going to say, all right, I'm looking for a 7-note away perfect fifth. The inverse distance is 12 minus 7, which is 5. So if I go up here, it's going to be 5. Then this continent shifted this way, so I have to go here for 10. Then 15. 12 minus 15 is negative 3, plus another 8 is going to give me, plus another 5 gives me negative 8. And then plus another 5 gives me 13. The only time we get up to 13 is when we go up 5 strings. 13 minus 12 would be negative 1, and then negative 2, 3, 4, 5. Let me try to count it out from here. We're going to go negative 5, continent shifted this way, so negative 10, negative 15. 15 minus 12 is negative 3. Negative 3 plus 5 is going to be negative 8, plus another 5 is going to be negative 13. 13 minus 12 is negative 1. Negative 1, 2, 3, 4, 5. So if I went from this E to this A, that would be a 5-note away perfect fourth. From the A to the E, therefore, would be a 7-note away perfect fifth. So if I go up 5 strings, I will always cross the fault line because I can't go up 5 strings without crossing the fault line. And the 7-note away perfect fifth will therefore always be 1, 2, 3, 4, 5 frets back. All right, let's do the next one. Let me do a quick joke here. This one will be a little shorter. I'll try to get, this will be the last one because we have to get through the other two. But I've been messing around with my jokes, and so I have to get them out there, or else I'll get backed up on the jokes, and then that's gonna, you can't let that happen. All right, so here we go. You know, if a vampire is basically half bat, like a vampire is basically like a form of bat, is the proper name for vampire crap guano, right? Because that's what you call bat droppings are guano instead of crap. So vampire crap is actually guano. So that means that you have to beware. Like if you ever hear somebody excuse themselves from the table because they need to, quote, take a guano, end quote, then you should be careful in that case, right? Because, and I think I've heard Gavin Newsom actually say that on one of his new podcasts. I might be wrong, but I'm just saying, particularly instead of like heading towards the bathroom after they say they need to take a guano, they vanish and you hear flapping sounds. That's not good. If that happens, you may want to have an umbrella handy. You need an umbrella in that event just to be safe. So I feel like because of how gruesome the whole blood-sucking thing is with vampires, it gets all the attention, that thing, which I mean, that makes sense, but not enough attention is given to the far more common everyday vampire-related problem of guano droppings. You get hit with guano droppings. That's that's also a problem that we need to do something about, It's not just the blood-sucking thing, although that we need to do something about that too. Maybe we shouldn't vote for those people, at least, that we might be a little bit better off. But anyway, seriously, I think the ability to dive bomb guano dropping attacks has to be one of the biggest perks of being a vampire. Even for those vampire type movies where being a vampire is like good because like your skin turns into diamonds and becomes like bulletproof and whatnot, and beautiful women like you and stuff and all that. Still, I feel like one of the best perks has to be the dive bomb guano dropping attack ability. That's like pretty amazing, Like when a vampire is insulted, he's like, I don't give a guano, man. I don't give a guano. I drop guano from 30 feet on your face. Seriously though, the world would be a better place if we could just get all the vampires to donate their guano droppings for fertilizer. That stuff's expensive, man. But the droppings for fertilizers, it's in high demand. Bat dropping fertilizer. So the movies get it totally wrong, portraying the skin as diamonds, as like the valuable thing. It's their crap that's worth its weight in gold. You become a vampire and you could just live on your own guano droppings. Well, that and blood, of course, I think, but still, maybe if you get rich with guano dropping revenues, you could buy like expensive synthetic blood or something, maybe. We're now on the 8-note away minor 6. This 6 representing the 6th position in our scale. This 8 representing the half steps from the root note, in our case, the A note, noting that the minor 6 is going to be different than on the major scale, as we would expect, because most of the minors from the major scale will be flattened, taking one step back, in this case from a 9-note away major 6 to an 8-note away minor 6. Now we're also looking at the 6, which is an even position in our scale. Therefore, when I do a chord construction, I'm going to have to name it something different, because we take the 1, the 3, the 5, the 7, that's the last note, and then we have to go around the horn again, the 9 being equivalent to the 2, the 11 being equivalent to the 4, the 13 then being equivalent to the 6. So we could call this then the 8-note away minor 6 or 8-note away minor 13 from a chord construction standpoint. Okay, so we're on our A. We're going to be going above it. Therefore, to find the 8-note away minor 6 or 8-note away minor 13, we have to take the inverse distance. Well, let's go this way. If I go on the same string, then I would go 8 notes up this way, but that would be quite far. So if I take this string, wrap it around in a circle, and then think of it as like a clock, and going one way around the circle would be 8 notes. I want to go the other way. Behind it then would be 12 minus 8, the inverse distance, which would be 4 notes. A 4 note away distance would be a major third. So the inverse of a minor is a major. The inverse of a 8 note away minor 6 will therefore be a 4 note away major third. So if I go 4 notes back, 1, 2, 3, 4, we're on that F. If I counted out from this A, 1, 2, 3, 4, if I went from the A to the F, that would be a 4 note away minor third. If I go from the F to the A, it would be a 4 note away minor third. If I go from the A to the F, it would be an 8 note away minor 6. Okay, now let's go above it. So I have to take the inverse distance once again. So I'm looking for an 8 note away minor 6 or 8 note away minor 13. If I go 12 minus 8 is a distance of 4. So is it 12 minus 8 is going to be a distance of 4. I'm looking for the F right there. Okay, so that means that if I go up between these strings, going up this way would be a distance of 5, and then would be a distance of 5 and then 4. Okay, I'm trying to think about my color scheme. I'm using this orange one. So let's count it up this way. If I'm on this A, distance of 5 and then back to 4. So from F to A, wait a second, that don't sound right. From here to 4, and it would be this way. Boom, 4. Man, got to get back, and the joke kind of threw me off here. So from F to A would then be a 4 note away major third from F to A. From A to F, therefore, would be an 8 note away minor 6. So if I go up one string, the 8 note away minor 6 will be 1 fret forward unless I cross the fault line, which would happen only on the B string. So if I was on this B string, it would be right here. So the idea would be, if I go up one string, the 8 note away minor 6, which could also be called the 8 note away minor 13, will be 1 fret forward unless I cross the fault line, which would only happen on this B string. This tectonic plate then shifting to the left, bringing from my vantage point this note this way, so it brings it back, right? So now I'm going to say if I go so if I go up one string and cross the fault line, the 8 note away minor 6, which could also be called the 8 note away minor 13, will be on the same fret. Okay, so then let's go up 2 frets and go out to here. 1, 2, 3, 4, 5. So if I go up 2 strings and cross the fault line, looking for the 8 note away minor 6 or 8 note away minor 13, 12 minus 8 will be a distance of 4. So I've got 5 going between these 2 strings. This fault line moved to the left. So I have to go this way to get to 10, and then this way will bring me back towards 0. So I'm going to say that's negative 10, negative 9, 8, 7, 6, 5, 4 to get to that F. So if I count it out this way, I'm looking for a distance of 4. So I'm going to say 5, and then this tectonic plate shifted, so 10. So negative 10, negative 9, 8, 7, 6, 5, 4. There's my F up here. So from this fret 10, top to bottom, would be a 4 note away major third. Bottom to top, therefore, would be an 8 note away minor 6 or 8 note away minor 13. Therefore, if I go up 2 frets and cross the fault line, the 8 note away minor 6 or minor 13 will be 1, 2, 3, 4, 5 frets forward. I wouldn't cross the fault line, though, if I started on the G or the D string. So if I was on this A and I go up 2 strings, it would be out here. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, a distance of 6 frets, which means it would also be 6 frets back. That's right in the middle. So the general rule is, if I go up 2 strings, the 8 note away minor 6 will be 1, 2, 3, 4, 5, 6 frets forward unless I cross the fault line, in which case if I look at this as my root and I'm going upwards to cross the fault line, which means that I'm looking at this continent moving to the left, bringing it closer. Therefore, if I go up 2 strings and cross the fault line, the 6 note away minor 6, which could also be called the minor 13, is 1, 2, 3, 4, 5 frets forward. All right, let's go up to the next one. Next one. And we're going to go up to here. So now I'm going to say, okay, I'm going up 3 strings, looking for the 6 note away minor 6 or 13. And I have to look for the inverse distance, which is 12. The 8 note away minor 6 or minor 13. I have to look for the inverse distance, which is 12 minus 8, which is 4. Hopefully I didn't say that wrong for too long or confuse too many people with. So we're going to say above it then is going to be a distance of 5. This whole fault line shifted to the left, so I have to go this way to get to 10, and then 15. There's only 12 notes in the musical alphabet, so I'm going to say, so wait a sec, something went wrong here. So I'm looking at this F, and let me do that again. I've got 5, 10, and then 15. 15 minus 12 is -3, and then 4. That makes sense, right? So then if I do it this way, it's going to be 5, and then this shifted this way, so 10, 15. 15 minus 12 is -3, and then 4. So there's my F. So from this F to that A would then be a 4-note away major third. From this A to the F, therefore, would be an 8-note away minor 6 or minor 13. That means if I go up 3 strings, the 8-note away minor 6 or 13 will be 2 frets back if I cross the fault line, but I wouldn't cross the fault line if I started on the G string. So if I was on like this A, I can't do that A because I can't see it. So I have to go to this A, there's the A, and I go up 3 strings, then I'm looking for the F. It'd be right there. Actually, I could see it right here. What am I doing? It would be right there, A to the F. Boom. Let's do that. It's easier to see. So the general rule is if I go up 3 strings, then the 8-note away minor 6 or minor 13 will be 1 fret back unless I cross the fault line, in which case if this is my root, then this tectonic plate shifted to the left, making the distance greater. So that means that if I go up 3 strings and cross the fault line, the 8-note away minor 6, which could also be the minor 13, is 2 frets back. Okay, so then let's go to the next one. And we're going to go to the one up here. Okay, so now I'm going up 4 strings, which means I'm always going to cross the fault line because I can't go up 4 strings without crossing the fault line. Looking for the 8-note away minor 6 or minor 13, 8-note away minor 6. I'm just trying to think in my mind, you know, if I'm looking at this string and I'm looking at it from the bottom string, what would be my cheating method to kind of do that a little bit more easily? I could say, well, this string is the same as this string up top. So whenever I'm looking at this string, it might be easier oftentimes to say, well, the same note is on top. These 2 strings are the same, and then measure it going down instead of going up, right? So then I can say, well, these 2 notes are, so if I'm trying to find this one right here, it might be easier for me to say, well, let's measure it from this A because I know these strings are the same, right? I could do that all the time with other octaves as well, but I just want to point that up with this particular string. It might be the easiest way to go, right? And then I'd say, well, now I don't need to look for the inverse distance. I can just look for the distance of 8 because it's an 8-note away minor 6 or 13, which would be 5, 6, 7, 8, right? Or I can count it up this way, which looks for the inverse distance. So I'm looking for an 8-note away minor 6 or 13, and therefore I have to take 12 minus 8, which would be a distance of 4, which would be 5. This tectonic plate shifted to the left, so 10, 15, 15 minus 12 is -3, plus another 5 would be a -8, and then -7, 6, 5, 4. So let's do it from here. So we've got -5, and then this plate shifted that way, so -10, -15, 15 minus 12 is -3, plus another 5 is going to be a -8, and then I go -8, 7, 6, 5, 4. So this F right there. So from this F to the A would be a 4-note away major third. Therefore, from the A to the F would be a 8-note away minor 6. So that means if I go up 4 strings, I will always cross the fault line. Therefore, the 8-note away minor 6 or minor 13 will always be 3 frets forward. All right, let's go to the top string. Top string, 1, 2, 3, 4 back. So once again, I would probably do my cheating method there, or my shortcut method, which would be, let's find it on the same string. I'm looking for an 8-note away minor 6 or minor 13. So I can look for a distance of 8 this way, or I can go to the shorter distance behind it, inverse distance 12 minus 8, which is 4 notes back, 4 frets back. would be here, and that would be the same on the top then. That's one way I can think of it, but let's count it out. I'm looking for the inverse distance of an 8 note away minor 6 or minor 13. 12 minus 8 is a distance of 4. So I have 5 here. This fault line shifted to the left, so 10 here. 15, bringing it down. 15 minus 12 is going to be 8 plus another 5. It gives me 3 plus another 5. I'm going to say negative 8. And then this is the only time I have to add another 5, which would bring me from 8 to 13. 13 minus 12 is negative 1, negative 2, 3, 4. Just there it is. So let's try to count it out from here just for practice. 5, this shift this way, so 10, 15, 15 minus 12 is negative 3, plus another 5 is 8, plus another 5 is 13, 13 minus 12 is negative 1, negative 1, 2, 3, 4. So from this F to the A would be a 4 note away major third. From the A to the F, therefore, would be an 8 note away minor 6. So if I go up 5 strings, I would always cross the fault line, which means the 8 note away minor 6 or minor 13 will always be 1, 2, 3, 4 frets back. All right, let's try to do the next one real quick. I won't do another joke in between because we're running way long here with our 3 ones that we got to get to. So this is a 10 note away minor 7. On the major scale, it would be an 11 note away major 7. It was flatted as we would expect to a minor, and the 7 represents the 7 relative position. The 10 represents the distance in half steps. It's an odd position, so although it's not in the 1, 3, 5, we don't need to rename it because it's still a same number. It's going to be an odd numbered 7. So there's our 7 right there for our interval. So if I measure it on the same string, it would be 10 notes up. So it'd be closer if I do the inverse distance behind it. 10 minus 12 minus 10 is 7. It's 2. It's 2, and that means 2 frets back. So there it is right there. So if I go back 2 frets from here, if I went from this G to the A, measuring from the G's perspective, 2 note away major second, remembering that the inverse of a minor is a major, inverse of a major is a minor. So therefore, if I go from the A to the G, it would be a 10 note away minor 7. Now, where is the major 7? Remember, the major 7 is right behind it, right behind the root. So that's the one you can play with sometimes. Rolling in, even if I'm playing an Aeolian, I can kind of throw that leading major 7 in as I go home to the root, giving me tension. That tension isn't normally there in a minor scale the way it is with a major scale. The minor scale gets jealous of the major scale because of that, although the minor has its own kind of cool things. But then the minor scale could just be like, you know what, I'll just add it even though it's not in the key and sounds wonky until I finish and get home. The wonkiness is actually cool because people are like, what is that? What is that? And then you go home and it's like, oh yeah, I see what's happening. Even though that's not how like you would express it or talk about it, but your mind is thinking that even if you don't know that that's what your mind is thinking. Okay, so let's go above it then. Let's go up here, and then we're going to say, okay, we're looking for the 10 note away minor 7, so we have to look for the inverse distance, which is 12 minus 10, a distance of 2. So a distance of 5 in between these. We haven't crossed the fault line. I'm going to call it negative 5, 4, 3, 2. So from here, I'm going to call it negative 5, and then negative 5, what is it? Yeah, 4, 3, 2. From top to bottom, G to A. From the perspective of the G, it's a 2 note away major second. From the perspective of the A, bottom to top, it's a 10 note away minor 7. Right. Okay, so let's go up to the next one. Let's go up to here and say, okay, now we're going to go up 2 strings and cross the fault line. So I'm looking for a 10 note away minor 7. Inverse distance is 12 minus 10 or 2. Negative 5 to go right above it. This tectonic plate shifted to the left, so I have to go diagonal to get to 10. And this is going to go higher. Negative 10, negative 11, negative 12, or octave, which I can also bring back down to 0 as I go around in a circle and then go from 1, 2. So I'm going to say, okay, let's count it out this way. So I'm going to go, okay, so it's going to go looking for a distance of 2. So we're going to say -5, and then this shifted this way, -10, and then 10, and then 11, 12, or octave, which brings it back down to 0, 1, 2. So if I go from this open G, to the A, that would be a 2-note away major second from the perspective of the G. From A to G, from the perspective of the A, would be a 10-note away minor 7 then. So if I go up 2 strings, then the 10-note away and cross the fault line, the 10-note away minor 7 will be 1, 2, 3, 4, 5 frets back. But I wouldn't cross the fault line if I started on the G or the D string. So if I started on like this A, for example, and I went up 2 strings to this G, it would be here. So look at my root position would be here, and then down here from the perspective of the root position, the tectonic plate shifted to the left. So that means the distance is going to be longer if I have to cross the fault line. So the general rule is if I go up 2 strings, the 10-note away minor 7 will be 1, 2, 3, 4 frets back unless I cross the fault line, which would happen on the B or the E string, the bottom 2 strings, in which case if I go up 2 strings and cross the fault line, the 10-note away minor 7 will be 1, 2, 3, 4, 5 frets back, 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 baby. 5 backs. All right, let's go to the next one up. Okay, so now we're going to go up 3 strings and cross the fault line, looking for a 10-note away minor 7. Inverse distance is 2, looking for a distance of 2. So this is going to be 5. This fault line shifted to the left, so I have to go diagonal to get to 10, then straight up to get to 15. There's only 12 notes in the musical alphabet. 15 minus 12 is -3. Going this way brings us back, or increasing, in this case towards 0. -3 plus 1 is -2. Let's do it from this A. So 5, and then this shifted this way, 10, and then 15. 15 minus 12 is -3. Going this way brings it less negative, -2. So from the bottom to top, or from the perspective of the G, top to bottom, it would be a 2-note away major second. From the perspective of the A, bottom to top, would be a 10-note away minor 7. So if I go up 3 strings and cross the fault line, the 10-note away minor 7 is on the same fret, but I wouldn't cross the fault line if I was on the G string. So if I was here and I went up 3 strings, it would be here. So you can see what happens from the perspective of the root position. If I move it where I have to cross the fault line, this tectonic plate shifted to the left from my perspective of where I'm measuring from. So that means that the general rule is if I go up 3 strings, the 10-note away minor 7 will be 1 fret forward unless I cross the fault line, which would happen if I start on either the bottom B or E string, in which case if I go up 3 strings and cross the fault line, the 10-note away minor 7 will be on the same fret. Okay, let's go to the next one. We're getting a little tired here. I'm not tired. 1, 2, 3, 4, 5. Being tired's for wussies. I could do this all day. All right. I got my matcha, the green tea, matcha. So I'm out of coffee. I got matcha. I like matcha though. It's a good break. Even if I had the coffee, I would drink it. But I need my coffee because someone stole my coffee, which is kind of annoying. A little problematic. My coffee is necessary. That's where I draw the line, man. That's where I draw the line. You take my glasses and I run around blind, running into walls. That's bad enough. But you take my coffee, the line has been crossed. The price has, okay, where was I? See, if I had coffee, okay. 10-note away minor 7, inverse distance is 12 minus 10 is a distance of 2. So we're going to say -5, and then this tectonic plate shifted, so -10, and then -15. 15 minus 12 is -3, plus another 5 is -8, and then going towards 0, -8, 7, 6, 5, 4, 3, 2. Okay, so looking for a distance of 2 from here. So -5, and then this shifted this way, so negative 10, negative 15, 15 minus 12 is negative 3, plus another 5 is going to be negative 8, negative 8, 7, 6, 5, 4, 3, 2. There's the G. So from that G to this A would be a 2 note, from the perspective of the G, it's a 2 note away major second, but from the perspective of the A, bottom to top, it would be a 10 note away minor 7. So that means that if I go up 1, 2, 3, 4 strings and cross the fault line, the 10 note away minor 7 is going to be 1, 2, 3, 4, 5 frets forward, and I'm always going to cross the fault line if I go up 4 strings, because I can't go up 4 strings without crossing the fault line unless I'm thinking about going around the top of the guitar, which you can think about, but we're not doing that now. Let's go up all the way up 5 strings. Now, if I go up 5 strings, I'm probably going to cheat or use my convention. It's not really cheating. You know, I don't want to make it sound like bad. It's just good thinking. So we're going to say if I go forward, it would be 10 on the same string. So if I go 12 minus 10, the inverse distance would be 2 frets back. And if that's the 10 note away minor 7 here, it's also the same up top because it's the same note on the top string. But I could count it out, in which case, once again, I'm looking for the 10 note away minor 7, have to find the inverse distance. 12 minus 10 is 2, so it's 5 to go above it. This tectonic plate shifted to the left, so I have to go 10 this way, and then 15. 15 minus 12 is negative 3, plus another 5 is negative 8. And then this is the only time we have to add another 5 if I go a distance up here, which would be 5 plus 8 is negative 13. And then I could bring that down. 13 minus 12 is negative 1, and then negative 2. Okay, makes perfect sense. So I'm going to say, count it from here, negative 5, this shifted that way, negative 10, negative 15, 15 minus 12 is going to be negative 3, plus another 5 is a negative 8, plus another 5 is negative 13, but there's only 12 notes in the musical alphabet. 12 minus 13 minus 12 is negative 1, and then plus another 1 is 2. So then if I go from this G, the perspective of the G, top to bottom, that would be a 2 note away major second. Bottom to top, therefore, would be a 10 note away minor 7. So therefore, if I go up 5 strings, I'll always cross the fault line unless I think about going around the top of the guitar, in which case that means that the 10 note away minor 7 will always be 2 frets back. Now remember, as we think about this string down here, you can always kind of go around the top of the guitar and imagine it's going to be the same notes up top. So I could think about the same idea of saying, well, what if I'm on this A is kind of equivalent to this A, right? And if I wanted to think about this string, I could say, well, then it's 2 frets back. If it's 2 frets back, it's 2 frets back here. If I'm going below that A to this string, then of course I can think of the 10 note away minor 7. I don't need to look for the inverse distance, just a distance of 10, right? So then I can say this is going to be 5, and then 6, 7, 8, 9, 10, right there. And so if I count it out from here, so 5, 6, 7, 8, 9, 10, dun-dun. So top to bottom would be a 10 note away minor 7, which means, of course, bottom to top from the perspective of the G this time would be a 2 note away major second, and that would be the case. So that would be the case unless I cross the fault line, just to see it from below, because since we're on the bottom string, we're never going down. So I just want to touch on that perspective. If I go below the string, then of course I don't need to look for an inverse distance of 2, but just the distance of 10. Okay, makes perfect sense.